In the titration of a polyprotic acid lab, you are going to titrate acetic acid and an unknown polyprotic acid, and you are going to determine what your unknown acid likely is, and you're going to calculate the pKa and Ka for acetic acid. So let's talk about what you're going to do to determine that. So, I'm not going to go through calibrating your pH meter again because we talked about that in the last video. So you can go back and rewatch the first part of that video if you need a refresh on how to calibrate your pH meter. So let's talk about what happens when you titrate acetic acid. So acetic acid does not have a nice, neat little titration curve, or not quite as nice and neat as a strong acid. Remember, acetic acid compared to some of your other acids is weaker. In this case, we're going to use a strong base, sodium hydroxide, to do the titration. So let's say that we have our titration curve. So we're plotting the amount of sodium hydroxide that we've added versus the pH. And you would, of course, have your numbers on there, but we don't need that for this demonstration. What you're going to do then is you're going to have your curve, and let me put the curve in a different color just so it's a little easier to distinguish from the axes. And you're going to see a gradual slope up, and then it's kind of going to level off. So this point where you have this slope is what we call the equivalence point. So once we're halfway to that equivalence point, so once you know what the equivalence point is, you can kind of estimate on this flat line here where the half equivalence point would be. It's about halfway to the equivalence point. And you can usually see that looking at the milliliters of sodium hydroxide. So about halfway to that gives us our half equivalence point. Your pH at your half equivalence point is equal to the pKa. So on your graph, once you do this titration, you're going to find the equivalence point, and then you're going to find the half equivalence point. And the half equivalence point is where the pH at that point is equal to your pKa. So your lab handout walks you through how to set up your experiment and how much of your sodium hydroxide to add each time. So once you get that graph, and you're going to make this graph in Excel, then you're going to do your curve and find your equivalence point and your milliliters of sodium and your half equivalence point. So then after you do that, you're going to titrate a polyprotic acid. So let's look at what your graph is going to look like when you do that. So you're going to have your graph, and you're going to have the pH and your milliliters of sodium hydroxide. And when you make this graph in Excel, you will need to label your axes. So you're going to notice for this that you're actually going to have 2 points where it kind of levels off and then goes back up. So the first point where that happens is your first equivalence point. So we didn't get real fancy with the names here. The first point where you see this sharp increase in pH is your first equivalence point. And then the second point where that happens is your second equivalence point. So as with your acetic acid, you then will also have a half equivalence point. So this is your first half equivalence point. And at that point, the pH equals pKa1. Then you're going to have a second half equivalence point on your way to the second equivalence point. So about halfway to your second equivalence point, you have your second half equivalence point. And at that point, pH is equal to pKa2. So once you've created these graphs, and you'll make a graph in Excel plotting your milliliters of sodium hydroxide versus your pH, and then you are going to get your pKa, and then you will calculate Ka. So Ka, remember, if you know pKa, we take 10 to the negative pKa. So for acetic acid, once you get your Ka, you're going to calculate the percent air. And it actually gives you in your lab handout what the literature value is for your Ka for acetic acid. So percent air is calculated as your measured value minus your true value divided by your true value. So you're going to take what you measured minus, it tells you in your lab handout, the literature value or true value for the Ka for acetic acid is 1.8 times 10 to the negative fifth. So you're going to take your value minus 1.8 times 10 to the negative fifth, divide that by 10.8 times 10 to the negative fifth. Then for your unknown polyprotic acid, you're going to give pKa1 and 2 and Ka1 and 2. And in your lab handout, there is a list of polyprotic acids along with the Ka1 and Ka2, as well as Ka3 values, which you'll see sometimes. You are going to, based on the Ka1 and Ka2 values you got, determine which unknown polyprotic acid you think you had. And then you're going to give me an Excel plot of volume versus pH for acetic acid and your unknown polyprotic acid. So make sure that you include those plots as well. So make sure that you have submitted your purpose and procedure on Canvas, and I will see you in lab.